to, yeah, that works. Okay, can everybody hear me okay? We're not going to start for another like 4 minutes, but want to make sure everybody can hear me in the back. Cool. All right. Hey, got a few familiar faces here. Thanks everybody for showing up for a Sunday talk. We're right at about 11:30 here, so I guess we'll get started. Good morning. I'm Carl Fossen, if that wasn't obvious from the slides up here. And today we're going to be talking about attacking Azure environments with PowerShell. So, a little bit of background on me. I'm Abe Simpson in this picture. But yeah, I'm a pen tester. I work for a company called NetSpy. We're headquartered out of Minneapolis. I'm based out of Oregon, if that wasn't obvious, based off of the flannel today. But do pen testing. I've been with NetSpy for a little over 7 years as of this last week here. But do password cracking, social engineering. You can find me on the NetSpy blog, blog.netspy.com. And a lot of the information that we're talking about today, we've actually got blog posts up already that cover some of this stuff. So if you've read those posts, it'll be a little bit of the same info, but a couple of new things that haven't made it out to the blog yet. Cloud enthusiast is a strong word. I spend a lot of time in the cloud, but there's some interesting stuff. You can also find me on Twitter at @kfossen, where I'll be tweeting about this kind of stuff. So here's a quick overview. We're going to talk about this stuff, so I'm not going to spend too much time on it. So quick start here, dumping Azure data. So a little background on me. I've been doing a lot of work in Azure applications, deployments, subscriptions. We've got a fair number of clients that Do work with NetSpy that have moved a lot of their applications and infrastructure up to the Azure cloud, so we're getting asked more to do assessments on Azure. This includes application assessments, Azure Active Directory, Microsoft Online assessments, all sorts of good Azure stuff. So we needed something to automate some of these processes and some of these attacks. So, why do we want to get data from Azure? Well, as part of this process, if you're looking at a subscription that's got a couple hundred users, bunch of applications, number of network security groups, all sorts of stuff. You don't want to do that by hand. Going through the Azure portal and going like line by line by line gets a little tedious. So we want to automate all of this. And kind of an additional benefit of this is if there's any external pen testers in the room here, if you're guessing fall 2018 passwords right now, chances are those fall 2018 passwords for the domain will get you access to the Azure portal. What we're frequently finding is that just all users have read access to the Azure portal. It's just kind of a default setup. A lot of times people are not locking that down, so if you get standard domain credentials, you can just go to portal.azure.com, log right in, and enumerate a whole bunch of information. So it's handy for the infrastructure audits, external pen testing, and regular domain users are not typically locked down, so it's pretty easy to do this. And since it's the cloud, it's all available over the internet, so it's easily and readily available for external pen tests. So there's a few different ways that we can dump data from Azure. I talked about the most basic one up front here, just going into the Azure portal and copying and pasting things out. The graphical interface is nice. If you want to poke around and look at things individually, just log directly into the website. It's a screenshot on the side here of some of the services you can access there. But it's not great for scaling. It's hard to copy and paste IP addresses for 400 VMs directly out of the website. There's also REST APIs. You get some nice structured JSON data that comes out of those, but setting up the authentication for it and some of the JSON data formatting is not ideal for things like PowerShell commandlets, which we'll talk about next. You have nice pipelined objects that you can feed into other commandlets. So in the case of Azure, let's say that we've got network security groups, and under those security groups we have different machines with different rules. We want to pipe that list of security groups and machines into different functions for Azure to get additional information. So with that pipelinable data, it's easier to automate all of this stuff. A little bit harder with the REST APIs. With the PowerShell commandlets, which we'll talk about the dependencies next, you've got integrated authentication through the Active Directory libraries that are just inherently with these commandlets. So it's easy to do authentication, get that set up. The output's easier to handle. It's easy to output to CSV or text files, and it can handle data at scale. Like I said, you can pipeline these objects and get everything outputted very easily. Cons, really just kind of limited threading options depending on how you're setting up some of these pipeline objects. Threading can be kind of difficult, and if you're dealing with, say, a 10,000 user domain, that can take a little bit of time to go through all of the Active Directory groups and map those users back to groups. So that does take a while. I do have flags in some of these scripts that basically say don't dump the users and groups if that's not important. If you just want to focus on more of the services that are there, you can go ahead and do that as well. So for the PowerShell commandlet modules, there's 3 different ones that the Microburst tools rely on. So Microburst is the name of the tools repo where all of these PowerShell tools live, and we'll show a link to that in a minute here. But we make use of the Azure Service Management, or typically ASM. It's actually just Azure in the modules for PowerShell. Azure RM, which is kind of the slightly newer option. It's Azure Resource Management. And the MS Online, which really, if you're in a situation where you've got domain creds from an external pen test perspective and they've locked down the actual Azure management, you can typically still log into the Microsoft Office 365 portal and use the PowerShell commandlets that way and still list out all of the users and groups and service principals and still get a bunch of additional information that's handy for external pen tests. So that's kind of a fallback. I'd say 75, 80% of the time we're actually able to use the Azure modules when we get creds, so it's a little bit easier and you get a lot more data. So there is some existing research and tooling that's already out there. Actually, when the day after I submitted for the CFP, Azucar came out from NCC Group. Didn't quite fit my use cases. Tried it out on a couple of different subscriptions. Didn't quite work well in those environments. Feels a little bit more audit focused and pen testing focused, and as a pen tester, my focus is a little bit more pen testing. You can use my tools as kind of audit type tools, but Azucar felt a little bit more audit focused. It's got great reporting, so you might want to give that a try. There's also Azurite Explorer. That one seems like it hasn't been very actively maintained. I think that came out about 2 years ago initially. I just tried running it a couple of weeks ago on my example domain that we'll show some information for. And I was coming back with some broken Azure RM commandlets, so I think it's for previous versions of Azure RM. I should spend a little bit more time on those, and you'll see if there's any good data out of that. But if my tools aren't working for you, go ahead and check these out as well. So we do have some required reading here. If anybody's going to go out and do Azure pen testing after this, I would definitely say go out and find this book. Find it on nostarch.com. I don't actually know the author, haven't talked to them. This came out right before DEF CON, and it was actually kind of nice because I was prepping for this talk, and a lot of the stuff that's in here lines up with exactly what we're talking about today, including using example scripts from the book. I referenced a couple of those in the process of writing some of these scripts. They're basically just wrapping the Azure RM and Azure commandlets, so doing a lot of the same stuff. But definitely required reading. Go out and pick up a copy. It's a good read. So this brings us to Microburst. This is the name of the tool that we're going to be talking about today. It's a collection of PowerShell scripts, and basically, as the diagram outlines, we've got PowerShell commandlets that dump out credentials, config files, usable data. Works out for public file access, lateral movement. You can use all of this data to go throughout an Azure environment and potentially pivot into an internal domain from the cloud. So this is a quick list of the current functions and module dependencies. We're just going to get into these, so we're not going to spend too much time on that. But how to run it, pretty simple. Just use the PowerShell import module. Just use the PSM1 file. If you want to see exactly what's being loaded up or what modules are being used, use TAC verbose. Here's some simple command examples. These slides will be up online on SlideShare. I'll post these on Twitter. You can see the link at the very end here. It's just K Fossen on SlideShare, but I'll get those up hopefully end of day today. We'll see. But we'll talk about all of these different tools in some of our examples here. But first, we're going to give people a primer on some of the Azure services. So kind of dove right in up front about pen testing Azure, didn't really talk a whole lot about the actual Azure services. So let's take a step back and talk about what you can actually do with Azure. So with the Microburst tools that we have, we've got a number of authenticated and unauthenticated attacks. We dump out information for a number of different services. Since this is a stable talk and I'm already 8 minutes in, we're not going to have time to go through everything, but we'll touch on a couple of different services that we really focus on with the Microburst tools. So Azure Active Directory, or Azure AD for short. This is the first thing that we're going to talk about. I've honestly found this to be one of the most useful things to dump information about from an external pen test perspective. We guess those fall 2018 creds, log into the Azure portal, and then we're able to list out every single user in the domain. Okay, cool. That gives us opportunities to do more password guessing attacks, because typically we're starting with some OSINT, something that you might be pulling from LinkedIn, email addresses, anything like that. And this way, we've got a full list of all of the domain users. So that really opens up that surface attack area. On top of that, we can get phone numbers for, say, phone-based social engineering, getting a list of the enrolled devices if laptops are being enrolled with Azure Active Directory for device management. You actually just get a list of all of the host names that are deployed to specific people. So you can go ahead and line up, oh, host name 123 is tied to this domain administrator. Let's go target that box later once we get into the internal network. Third-party apps integration is also really handy. So once you've got those creds, cool, you can get into Outlook Web Access, the Microsoft portals. That's nice, but what about other third-party apps that are single sign-on, either with Azure Active Directory or ADFS? We can actually list those out from the Azure portal. So if you're integrating AWS or WebEx or your HR or Salesforce or something like that with ADFS, we can list that out, and as an attacker, we can start pivoting into those systems, which can be really handy. Last item that I listed on here for Azure Active Directory is guest users. So what we'll typically see in most Azure Active Directory environments is what's called a DC sync with a primary domain. So you'll have the company domain that DC syncs up to Azure Active Directory, which syncs the credentials and usernames and domain information up to Azure AD. And you can have guest users added to that Azure Active Directory. So let's say that I get access to an owner account on one of these subscriptions, I can go ahead and add my NetSpy account as a guest account in Azure Active Directory and get a little bit more persistence. Not necessarily the most OPSEC safe thing. You're being pretty obvious at that point adding a user. However, if people are not auditing those guest users that are on those subscriptions, you might be able to hide out there for a little bit longer. So I think we talked through most of the practical examples here. I think the one thing I didn't touch on was phishing. So enumerating all of those users and getting the additional email addresses, you've got a nice base for phishing, but pretty much talked about anything else. So next thing that we're going to talk about are Azure storage accounts. Now, Azure's got kind of a different structure for handling data within the cloud. Primary thing that we're really going to talk about today is Azure blobs. And easiest way to describe this is comparing it to AWS. If you're familiar with S3 containers, it's very similar to that. Microsoft probably wouldn't like that comparison, but it's the easiest way to describe it for people that are not familiar with Azure. So blob storage is just kind of unstructured, dump a file into a folder, you have it there, you can access it, you can set up permissions for it, access policies, which we'll talk about next. But from a practical example standpoint, we've done Azure assessments and taken a look at storage containers where we'll find config files, VHD files, which we'll talk about in the practical example, but basically virtual hard disks. Publicly available files that shouldn't be public, PII, all sorts of good stuff that you just shouldn't be able to find normally publicly. And you can also use this for hosting payloads, since what we're going to see here for the naming structure is this laser pointer is not going to work from this angle, but we see NetSpy Azure.blob core Windows Net. That's the storage account name. So NetSpy Azure is what we name the storage account. Blob core Windows Net is the URL to access the rest of it. Then you have folder structures behind that that cover the containers. We'll talk a little bit more about that when we talk about the enumeration, but that's a trusted domain. Coming from Windows.net, if you're trying to go out to the internet to pull down a payload, you're probably not going to get blocked for Windows.net. If you're going out to phishingdomain.com to pull down a payload, okay, chances that you're going to get blocked there are much more likely. So using a trusted domain from Windows might be handy for hosting some of your payloads. So for the anonymous blob enumeration, you can set what's called an access policy for the blob containers. So you've got the storage account, underneath that you've got the containers, underneath that you've got the blob. So per the container, you can set the public access level. Since permissions are hard sometimes and it's just easier to give everybody access, we've seen that container permissions are frequently used, which allow for anonymous read access for containers and blobs. Which means if you're an anonymous user who knows the storage account and the name of the container, you can list out all of the files. So a lot of this can be done with Google Dorking on the blob core Windows Net. I've actually got functionality built into the script that's tied to this to do Bing searches, because Bing's easy to do with PowerShell. But wrap Bing searches in here to expand the scope a little bit. So what this script will actually do is take a keyword. In the case that we'll show in the examples here, we'll just use microburst and do a quick search for that. So do some DNS brute forcing, potentially add a Bing search to that to identify additional storage accounts, and then iterate through potential containers at that point. Once we've identified a public folder, we use the Azure REST APIs to actually list out the files, because that's about the easiest way to do that. But like I said, we frequently find public containers with just all sorts of interesting information. So another Azure service that we're going to chat about here is Azure SQL. And Azure SQL is kind of interesting. What we're typically seeing it used for is just application services that need a database out in the cloud. So it's Microsoft SQL out in the cloud. But what we've actually found is that people will just open up access and keep those SQL servers wide open to the internet. Well, SQL servers can frequently be configured with weaker default passwords. One of my coworkers, Scott Sutherland, who wrote PowerUp SQL, has done a little bit of research into this space. And yeah, just like regular Microsoft SQL, Azure SQL can fall to some of the same pitfalls that you find with standard Microsoft SQL servers. So in terms of accessing that data, if you're an attacker who's got domain creds and gets into the Azure portal, you can actually just directly query databases if you have rights to them. from the portal. They've got a Query Explorer built into the Azure SQL section. Pretty easy to access. You can also access it from SQL Management Studio if the firewall rules allow it. By default, Microsoft does lock that down and makes you put exceptions in for your own IP addresses, but we've seen it where people are kind of lazy and want to open it up for multiple different IPs and just open it up everywhere. So some practical examples. We've seen development environments where those SQL servers are available, open firewall rules, and get in with a weak SA password, something like that. So this can be handy. I did have a bullet on here for Azure SQL used as a C2. Scott Sutherland did write a blog post about this. It's out on the NetSpy blog, but since Azure SQL is going through those trusted Microsoft domains, you can just go ahead and make your C2 communications out through that and use that Azure SQL database as that pivot point. So that can be pretty handy. So the last thing I'm going to cover on the services side of things prior to jumping into the demo here is passwords. So passwords can be stored in a number of different places in Azure. You've got key vaults, app service configurations, and automation accounts, kind of the primary ones that we're going to focus on. Key vaults, you can store all sorts of great information in here. What we've found with key vaults is those are usually typically locked down a little bit more, but if you've got owner rights on that subscription, you can go ahead and give yourself access to the key vaults as well. So we find keys, certs, passwords, all sorts of really good stuff that you would expect to find in a key vault there. App services are basically rapid application deployment options within Azure. So let's say you want to fire up a web application, you just point it at a GitHub or a source code zip, anything like that, and you can rapidly fire up these app services to have web services available. It's great for scaling. It's pretty handy. We've found that it can actually kind of work for phishing domains as well, since by default they issue you a Microsoft domain right off the bat. But that's covered in another blog post that's up on the NetSpy blog. But when we're doing that, you can actually get credentials for FTP and I can't remember the other service that's available. We'll see it in the demo. But you can get credentials for actually just deploying that. So let's say that you want to throw a web shell up on one of these app services configurations. You could potentially do that by capturing those credentials for the deployment credentials. In addition to that, let's say that they've got Azure SQL set up for those application services that they're running. There might be database connection strings included in those app service configurations. So again, pretty handy to get access to that. Automation accounts we'll cover here. Automation accounts can be used to automate things in Azure. And typically things are set up with a username and password to run those automation jobs. The script that we're seeing right here is actually the script that we'll use in the PowerShell script to basically get those credentials out of Azure. So really all it does is it creates objects for the username and password, writes them to the output. We upload that script up to an Azure runbook, run the runbook. Typically do this with a pre-generated like 12-character upper lower. Looks fairly random. It does show up in the logs, but we delete the runbook after the fact, so it just kind of looks like a randomly named. You'll see it in the example, but it looks like a randomly named job that shows up in there. And then we've got credentials from the automation accounts. So, quick demo here. Since I think we got about 5 left, right? About 5? Okay. So this is a sample escalation that kind of comes out of a couple of different things that I've seen in the actual live environments I've worked with. First thing that we're going to do is enumerate a public blob storage container. There's a number of different ways that we can run into these public storage containers, either authenticated or unauthenticated. In this case, we will be unauthenticated. We'll find a microburst container and get a VHD file. I'm not going to read through all of this because I'm just going to show you the example, but wanted to prime you for that right here. So the first thing we're going to do is import the module for microburst and run as soon as I can hit play here. Come on. There we go. So we'll import the module and use the invoke enumerate Azure blobs with the base of microburst. So you can see we found a storage account for microburst.blob.core.windows.net. For those that are interested in diving into this and attacking my subscription, I've burned this one to the ground already, so that's why we're using videos, because it didn't make sense to put something out on the cloud for public people to start attacking. So anyways, what we found here is a public file available under the test container. So we did DNS brute forcing to find microburst.blob.core.windows.net. and then enumerated a test folder or container within there and listed out the files. So we've got a URL for test.vhd, which will go incognito here and show that we're not currently logged in anywhere. It's super exciting here. We're going to download a file. So we'll paste that. And instead of making you wait for 30 gigs of data to come down here, we'll just fast forward in time. And we've got the test VHD file. So we're going to right click and mount that. Pretty easy in Windows. And we've got access to somebody's hard drive. So in this case, what most likely happened was a developer wanted to use some kind of gold image or make a backup of the hard drive here. And that ended up in a storage account. We've seen this happen before. And what we're doing now is pulling the SAM and system files to pull the NTLM hashes for the local administrator account. So if anybody's used Kane to do this before, it's just a nice, easy GUI to show you guys what we're doing. But pulling the system file, grabbing the system key, copying and pasting it, and in a couple of seconds here, we should have the local admin credentials right there. Cool. So what can we do at this point? We've got local admin username and NT hash. We can potentially crack the NTLM hash, do a number of different things in that regard here. But in this case, we'll just pretend that we use Hashcat and cracked it. AZ admin pass. All right, cool. We've got the local admin pass for this VHD file. Where do we go from there? Well, if we're an authenticated user, we could potentially log into the portal, backtrack a little bit, figure out where the server is. If RDP is enabled, we could potentially go in that way. The VHD files are literally just virtual hard drives, so we can go ahead and load that up in Hyper-V. We've got local admin creds. We can just log directly in. You potentially modify SAM system or SAM file on there and give yourself access, but since we've cracked creds, it's pretty simple to just do this. So in this case, kind of a more practical example, if this VHD file has applications that are specific to the environment that you're attacking, you could potentially use those applications natively within that virtual hard disk. So that's nice. Alternative, we could just RDP in after we've identified the RDP interface, run Mimikatz. In this case, for proof of the demo, we got access to the K-test account. This is a domain joined account. And hey, cool, we got credentials. In this case, just NTLM creds. Alternatively, since we've got access to that hard drive, we can go ahead and use SecretsDump to pull off the cached credentials. This is a slightly more realistic option because if you're coming from an unauthenticated perspective, chances are you're not going to have that external IP address for RDP to get access, or RDP is limited. But since we're getting domain credentials at this point, we went ahead and cracked this randomly generated Microsoft password. The Azure Active Directory passwords are typically, I believe, 4 alphanumerics, 4 letters followed by 4 numbers. I added some exclamation marks for a little bit more entropy here. But in this case, let's pretend that we've got domain credentials. And we'll go ahead and log in directly through the Azure commandlets and run some scripts. So we'll just go ahead and connect the Azure RM account here. We'll be prompted for our credentials just using the native libraries for Azure Active Directory login. So we're going to use this K-test account. In this case, this account has owner rights. We're kind of cheating here for the demo, but for sake of time, and I'm pretty much running up on time here, we're just going to go through dumping the Azure domain info. It's going to prompt you for which subscription you want to use. You just select that, and it's going to dump out this information. So this will start spinning through a whole bunch of information that's going to start dumping. For sake of time, since I think we're coming up about a minute here. Okay. So we won't sit through all of this, but these slides will be up online. The other thing that we're going to do next was dump out all of the passwords for that subscription. We'll just get that video started here. And basically, we're already logged in as that K-test account who had owner rights and had access to all of these different password stores here. We're just going to output that to OutGrid view. Use Microsoft Burst Demo here. You'll see the example runbook job that pops up here as well in a couple of seconds after we get through app services. And that's kind of the end of the demo. So while we're waiting for this to wrap up, we have like probably 30 seconds left. Any questions? Yep. So the question was, does the script do the DNS brute forcing? Yes, yes it does. Yep. You can. So that takes a base word list that you can pipe into that, or you can do a folder permutations as well. So there's a permutations file that does like -dev, -test, -azure, that kind of stuff. Any other questions? Nope. I'm getting the stop, so we'll wrap up here. There's some fixes, conclusions. If anybody wants the info, it's on this last slide here. But thanks everyone for coming to a Sunday talk. Really appreciate it.